Let's see another binary tree search problem. That's from the LeetCode. It's a lowest common ancestor of the binary search tree. So let's try to understand this problem. This is the binary tree and it's given 2 and 8. So 2 and 8, and we want to return 6 because this 6 is the parent of 2 and 8. So that's the lowest common ancestor of binary tree. Let's see another example. For this also, like if someone, or like if the input is 7 and 9, and we want to know what is the parent of this 7 and 9. So 6 is also a parent, 8 is also a parent, but we want to know lowest common ancestor. So this is the lowest common ancestor. So for 7 and 9, 8 is parent. That's a common ancestor, lowest common ancestor. Let's see another example. In this example, it's a 2 and 4. So 2 and 4, and for the 2 and 4, 2 is parent. For the 2 itself, 2 can be the parent. Each node can be parent of itself also. So for the 2 and 4, parent of 4 is 2, and the 2, for the 2 itself, we can say 2 is the parent itself. So for each node can be the parent for itself, because that happens if there is only one node. So in that case, so this is the condition. So in this way also, for the 2 4, we have to return this 2. So a strategy for solving this problem is to search these items, like given items, like let's say for 7 and 9, we want to find out what is the parent of 7 and 9. Then we need to iterate this, and we need to know like where this exists. And we know that the property of binary search tree is, one of the property is every items in the left side is lower than 6. For 8 also, if you see, every item in the left side is lower and the right side is that greater. So for this also, if you take for 2 example, for the right side you see every item is bigger than 2 and the left side lower. So that is the one of the property of binary search tree, and we are going to utilize that property. So if we want to know what is the parent of 3 and 5, then we can start from here and we can search this 3 and 5. This item is less than 6 or not. If 3 5 is less than 6, so of course it is less than 6, then we'll move our search in this direction, left direction. If this item exists in a right side, then we'll move forward with our search in the right direction. So that's the logic we're going to use here. So let's say we are here and we'll check 3 and 5 is less than 6. Then we'll move the left pointer. Again we'll check 3 and 5 is less than 2. No. 3 5 is greater than 2. Yes. Then we'll move to the right direction and we'll come here 4 and we'll check 3 and 5 is less than 4. No, 3 is less than, but 5 is not, so we cannot move to the left direction. And again we'll check 3 5 is bigger than 4. 3 is not, but 5 is bigger, so we cannot move to the right direction also. If the situation comes like where we cannot move to either left or right, then this is the answer. 4 is answer. So let's see in this scenario 2 and 8. So we'll check 2 and 8 is less than this 6. 2 is less, but 8 is not less, so we cannot move to the left direction. Again we'll check both item. It's greater than 6. If it's greater, then we can move to the right. but 8 is greater but 2 is not greater, then we cannot move to the right also. So when the situation comes where we cannot move to the left and we cannot move to the right, then the main node, this node will be the answer. So let's write the code for this. So I can check the condition, like if root is nil, then return nil. Otherwise you can check if this p dot val less than this root dot val and q dot val less than root dot val. And if this condition is true, then we can move to the, we'll continue our searching in a left direction. So we'll go there. So we'll call the same function and we'll go to the left direction. So root dot left, and you can pass the same pq. Else, if you can check p dot val greater than this, p dot val greater than this node, or that is root val, and also q dot val greater than root dot val. So in this case we can move to the, we'll continue our searching in a right direction, and whatever it returns, we are going to return that. Else, if you cannot move to the left and right, then just return the root. So return root. Let's check for the same things, 6280. So come back to the description, 6280, same thing. This should be root dot right. Because it's greater, we can move to the right. Okay, so it's accepted. Let's dry run one more time. Let's assume this time, like this will be easy, but let's see dry run for the 3, 5. So we want to know the parent of 3 and 5. Then we'll check 3 and 5 so less than, so we'll move to the left direction. So here this call, again we'll call and go to the left direction, and from here this item is greater, then we'll move to the right direction. So this call will happen, and then we cannot move, then we'll return 4. So this will return 4, and then at the top we'll get that the 4 as answer. So this is the Golang solution. Let's see the Java solution. It's the exactly same logic. So we have put here, so root null, return null, or so less than p and q less than root, move to the left direction. If it is greater than p val and the q val greater than root val, move to the right direction. Otherwise return the root. So that's all for now. Thank you.